go. All right. Hi, everybody. Welcome. Thanks for coming. Happy Wednesday to you all. Today we're going to be talking about some machine learning stuff that our friends over at Cash App have been pulling together. My name is Jason Hand. I'm a senior developer advocate at Datadog. And I'm really excited to be up here on stage with my friend James to co-present some of the things that they've been doing at Cash App. So James, do you want to introduce yourself?
Yeah, thanks so much, Jason. Hey everyone, I'm James. I work on machine learning at Cash App. Thanks so much for taking the time to come here. I know there's a lot of talks going on, and you're probably already really exhausted from previous talks. So thanks so much for making the time to come here. So for those who don't know what Cash App is, it's a financial app that allows anyone to easily send, spend, or invest their money in stocks or Bitcoin. And I'm super excited to be with you all today to share the story of Cash App and Cash App's ML platform. I'm not going to talk too much about Cash App. I'm mainly going to focus on the ML platform. So a quick agenda for the day. First, I wanted to tell a little bit of an origin story about why we built our own ML platform. And after that, I want to go into some of the different moving parts and highlight some of the problems that you're likely going to have to solve if you're doing the same. So hopefully we can give you a bit of running start if you're going to do something similar in your organization. So going back, I could just talk about the ML platform, but I don't think it would exist for where we are today, except if we had that historical context in the journey. And so I want to go into that background, and I think it'll give a bit of a perspective on like where we landed today and how we got there. So let's go back to the start of 2022. I was working on Cash App's support ML team, and I was focusing on applying machine learning to the customer support team, the customer support domain. And so for the previous year, we've been working on ramping up our offering, and we're using a lot of existing infrastructure that we had available to us from the company. But the weakest part of our stack, and the part that we wanted to try and make a little bit better, was the model hosting. We relied on existing infrastructure, and it wasn't built for the model types that at the time were larger, like transformer type models. And so a little bit about our existing model hosting solution. It was the part of our stack where we wanted to wave a magic wand and try and fix. And so it had bad P99s. That meant that the slowest requests that we had were really slow. They were too slow for the use case that we wanted to use them for. We also couldn't see what was wrong with the system when things were going wrong, and we couldn't diagnose any of the performance issues. And we had this unavoidable overhead latency. So no matter how much we optimized our models, we couldn't really get to the bottom of there was just that little bit of the request that we couldn't change at all. So when we were thinking about what to invest in here, we knew that we wanted something stable. We wanted something that worked all the time and didn't go down. We wanted something observable, something that we could dig into the internals, see what was going wrong, and diagnose any issues. And we wanted it to be uncomplicated. We wanted everyone across the team to be able to understand how it works and to be able to dig in if there was anything that was going wrong. And this final point is we wanted it co-located with our other services to try and avoid any of the overhead latency that I mentioned on the last slide. So basically in the same cloud. So a little bit about the journey. We explored a bunch of different hosted solutions and found that SageMaker solved all the problems that we were encountering. And we did some stress testing with it, and it held up to the traffic that we expected to be sending through the system. So we found that it fit our requirements. Really, it was it seemed almost too good to be true. It was fitting everything that we wanted to do. But we had a bit of a question that we hadn't quite yet solved after all this initial exploration, which was how to integrate it into our system. Now, these were some of the options that we had in front of us. We have a lot of different services at Cash App. I think a lot of you probably work at larger organizations, and it's not just one computer sitting in a room that you can just talk to. We have a lot of different microservices and some not so microservices, and different applied ML teams work across a number of these services. And we had to decide where to call SageMaker from.
So you said you have a lot of services. Maybe you can tell us a little bit about what that means. Give us a little bit of idea of the stack.
Yeah, for sure. So here's a little bit of context on that. This probably looks really similar to how some of the services look like in the rest of your organizations. So there's ML-only services, there's product services, there's mixed services, and they talk to each other by a mix of like gRPC or HTTP requests, and they listen and consume events off an event stream. So pretty standard stuff.
So how does this sort of correlate or relate to the structure of your teams? What's the relationship there?
Yeah, that's a really good question. We totally didn't plan this. So our teams, we have a standard like applied ML team at Cash App is composed of modelers and engineers. And they focus on different areas across, where we can apply ML to the product. A modeler is generally responsible for training and packaging models. So they're the ones that are, in the notebooks, working out sort of how we can solve a particular problem with machine learning. And they also define the features that we need. So, trying to look at the data and be like, okay, cool, I can make this feature and plug that into the models. They also pick the model architecture, tree models or NLP models, depending on what the use case is. And they also help optimize model performance. But on the other hand, this other role that we have, which is a machine learning engineer, they build the data pipelines. Clicker. So they build the data pipelines, which is taking data from all different parts, like the product, putting into something that's like digestible in an ML system. They also build and support adjacent services. We build a lot of services in Golang or Kotlin or Java, and so they're responsible for that. They also integrate it with the product, because at a certain point you want to get the ML predictions into your product. That's usually something that's handled by machine learning engineers. And then at the end of the day, you have to keep that online inference online, and that's part of their role. But in reality, the roles are pretty fuzzy, and it's not really like you only do one role or the other. It's more like a spectrum, and you go across. So yeah, back to where we were before. We had this decision to make, which was where to build our SageMaker integration. And these were our options.
So James, when we first met, we talked about the journey and what we wanted to share today. You were talking about how there was two efforts kind of taking place at once, two roads, two paths. Maybe you can share a little bit about that too.
Yeah. So at the same time that we were exploring this, there was another service that was starting to get some traction from a different applied ML team trying to solve a really similar problem. And that service's name was Gondola. The name makes more sense, I promise, when you take into account that the name of the cloud platform is called Ski, or Shared Kubernetes Infrastructure. And there's also some other services that are called Chalet and Attendant. So Gondola came from a different applied ML team, and the focus there was to deploy containerized Python models in a Kubernetes cluster. It was meant to be really low latency, built from the ground up, and it allowed for people to iterate a bit more quickly without any of the tech debt from the previous ML hosting solutions that we had. But it turned into a lot more, and I think a lot of people can probably relate to this, is when you have side projects that come out of certain teams, they sometimes turn into main projects in themselves. What we saw in Gondola was an opportunity to collaborate, and at the end of the day, we ended up choosing that existing service for everyone option from that table before. And we built the SageMaker integration directly into this new service, Gondola, and we collaborated with the other applied ML team to do so. It really helped us refocus our problem from, okay, solve hosting for support ML, into let's try and solve hosting for all of Cash App. There are also all these benefits that, work that we didn't have to do, like spinning up the service, exposing an API, integrate with all the different parts of our app. I wanted to pause for a second and just talk about, I guess, generalizing this in general. When you're trying to talk to external platforms, there's a pretty big benefit to abstracting that away into one spot, because if you want to talk to an external service, if everyone has to do that, you suddenly have to build all those different integrations, and suddenly okay, you want to change to a different service, you have to rewrite all of those integrations. So if you build in one spot, it kind of reduces your vendor lock-in, and it changes the question from build versus buy to okay, we can buy, but we can just put a thin layer of build on top of the buy and take advantage of everyone sending all these requests and scale into the single platform. So that's how the Gondola team got its start. And one group needed something, and another group had a shared interest, and suddenly we had built something that had begun to scale to the entire organization, and it deserved its own team to run with it. And so today, that's all that context. I wanted to share today like a non-exhaustive collection of stuff that we've learned building out our ML platform. And I like to think of it as more than just like a single service. It's really the sum total of all the cool things that we've done to enable our ML organization to move quickly, accurately, and have fun doing so. And that means, from sneaking in at the end of the training pipeline to helping folks package their model, there's really a lot that you can do to solve problems at scale here. So I want to share this story from the perspective that, you're in your organization, you're building an ML platform, and, maybe these are some things that can help if you're trying to tackle the same sort of problem. Now, there's a lot involved in shipping ML solutions to production. If we talked about everything, I think we'd need several days. And I don't think you guys want to hear me talk for that long. So today I really want to focus on model hosting. Not to say that the other parts are less important, but let's stick with that. And we're going to start by going through like a typical model's lifecycle, and then look at some of the stuff that you can build to make it easier, better, and more efficient to ship models to production. I'm also going to say that we're going to start at the package step. Like in general, you train a model, you package it up, you deploy it, you talk to it, hopefully it's working. You monitor it, make sure it's working, and then hopefully, if you're successful, you're probably going to write a new version of it. So you'll decommission the old one and start again from scratch. We're going to start at packaging. Another team handles the training tooling, so I don't want anything to do with it. I'm just kidding, but we want to assume that we're at the end of the training pipeline. And so we've got a trained model, and we're running inside some kind of Python runtime, like a Jupyter notebook, or at the end of a prefect training pipeline. That's where our platform gets involved. And there's huge benefits here, is that you can build tooling at the very end of your training pipeline so that you can tell people like, okay, here's how you package their models. You can build a Python library, and that's what we've done. So it allows people to, easily package their models in the right way for your platform, attach the correct metadata, do any sort of validation, integrate directly with MLflow. So it means that you get like a lineage from training to production. And I think the benefit here is if you do that at the end of the training pipeline, you can just write some Python code that people can import and use. The way that we do that, and a little bit of it, is that we have a metadata file that we call gondola.json. And what it is it's a replacement for if they were going to fill in all of this through the UI. So it allows people to take this configuration step and put it into the code. I guess there's some of the stuff that we put in there. We have like inputs and outputs, which are pretty standard for the model. Some metadata like name and description. It's also a really good opportunity to do feature packing. So generally models have a bunch of different features that they expect, and it can be pretty inefficient to keep sending all those feature names. So we have a spec inside that file that allows you to specify like, okay, so these are the first 3 values, just send them directly like inside a tensor, and that means that you can optimize that request response pathway. Similarly, like it has configuration for something like imputation, which is like default values. So stuff like LLMs, they have a lot of parameters. You probably don't want to send them every time you're doing inference. So if you build this directly into the like upload step of your model, you can save a lot of time. Okay, so you've got the trained model, you've packaged it up, super easy because you've built tooling that makes that process a cinch. Now what? You probably want to deploy it, right? That's the whole point of it. So we have 2 approaches here. Now, SageMaker has a lot of features, and we're just customers, so we're far from the experts here. I do recommend checking out their documentation if you're starting to do an integration with SageMaker. But the 2 approaches that we've found is, one is to use isolated single model endpoints. These are really good for consistent traffic. So if you have a model, you know that it's getting 5, 10 QPS queries per second, really straightforward. But you don't ever want to have that contend for resources. Single model endpoints are really great for that. And that's one of the options that we've built for our users, that they can select a single model endpoint, know that it's not going to share any info with any other models. On the other hand, there's multi-model endpoints. These are essentially, you can think of them as like shared infrastructure for models. And they take a little bit better advantage of hardware. So if you have lots of different models sitting on that hardware, but it's sort of like you've got distributed requests coming through, they're not super stable, it's just whenever something comes through. Having that sort of capacity for models allows you to maybe have more models than there are like instances and save a bit of money with that shared infrastructure. So the way that they work is that they dynamically bring models into memory as needed. So a request comes in for a model, the instance is like, okay, cool, I don't know, I haven't seen that model for a while. Pull it into memory, handle the request, and then the next request that comes through is a little bit quicker. But there is a bit of a downside there, is that that first request can take a little bit longer. So my pro tip there is to try and co-locate your models in the right way if you're going to tackle this shared infrastructure approach. Some different ways that you can group that that we've explored is grouping by similar characteristics. So if you have a bunch of different models that are really similar, they're all tree models, or they're all like for some pathway where they have sporadic traffic, that's really good. We also group by team or use case and cost center. So if you want to monitor the cost of the hardware, and you want to know, okay, this hardware is for this team, and we want to make sure that they know how much that costs, that's a really useful way to do it. What we've done here is we've built a little bit of an abstraction on top of these multi-model endpoints. We call them deployment destinations, and they integrate with internal tooling like LDAPs or Slack channels, and it allows customers to reason about groups of models without understanding the internals of SageMaker. And I really recommend that you do the same if you're building something for like multiple teams within your organization. You probably don't want everyone to have to understand SageMaker. Okay, so wherever we've gone so far, like you've trained a model and you've packaged it up and you've deployed it somewhere. It's probably not very useful unless you want to talk to it. So let's work out how to do that. Some of the things you might be thinking about if you're going to talk to a machine learning model is how are you going to talk to it? Are you going to talk to it asynchronously? Are you going to like publish an event and then take it off the event queue, do an inference, put it back on? Or are you going to talk to it synchronously directly? Like, are you going to send a gRPC request, say, hey, give me an inference and get it back? You also might be asking, like, who's going to talk to it? Is it going to be a service? Is it going to be a rules engine? Is someone going to click a button and a prediction shows up on a screen? And also, like, what are your load expectations? There's pretty different provisioning patterns if you're going to like have a model that's going to handle maybe 1 query per second versus something that has to scale to like 10,000 queries per second. So I guess with all of this, the questions you should be asking yourself is like, what are you going to abstract for your customers? If you're a platform team and you're building like an ML system, you have to often be thinking about like how much can you take off all of your customers and solve it at an organizational level. Yeah, so here's a little bit about our inference architecture, really simplified, so not to bore you, but we have a bunch of different calling services that could call our system for an inference. These are things like rules engines or services, or even like a feature service that's doing some sort of aggregation or like graph resolution. They say to Gondola, hey, can you please give me a prediction? Gondola knows that they're talking about this particular model, but has to look up where that lives in SageMaker. And we've solved that by just having like an in-memory store, so it's super quick. Gondola knows where that model is, talks to SageMaker, gets an inference, comes back.
So James, one quick question I had on this as we were putting this together is, over on the right in the Amazon SageMaker at the top, we've got MME1, multi-model endpoints. I was a little confused why we had multiples of one. Maybe you can explain a little bit of that?
Yeah, that's a good question. I also, when I was looking at these slides, I was making sure I hadn't made a mistake. Because I saw, I was like, oh, hang on, why does that say one multiple times? But the reason is because the MMEs that you have, and this is something that works in SageMaker, they scale horizontally as needed if you set up the right auto-scaling configs. And for us, that means like, if you're like, okay, I have 100 models sitting on a single like SageMaker multi-model endpoint, you're probably going to want to scale if it's getting a lot of traffic. And so if you put the right auto-scaling config in, that one can scale horizontally automatically.
Makes sense.
OK, so doing inference. One of the problems that we encountered is that if you're trying to solve this at an organizational level, you have a lot of different applied ML teams doing machine learning. There are different models that have different request and response signatures for inference. What we found is that the best way that we could solve that is to run a reverse proxy inside the container so that from externally, you're just calling the same, I guess, with the same signature to our service, and we do the translation under the hood. That means that we can massage the request directly inside the container to the right format, and it also allows us to build in support for different model servers. So that could be Triton, it could be TensorFlow serving, or anything else. And because we're running a different process inside that container already, it means that we can do some fun stuff like publish additional metrics. Here's what that looks like. So you have that SageMaker MME instance. Inside that, generally people are running like a Docker container. What we've done is inside that Docker container, we run two processes. One is what we call homogenator. Yeah, well, that's like, you know, from the concept of milk. But yeah, it makes everything look the same. So you have homogenator with one process. All the requests come in. They get translated to the right format for the right model server. And then in this instance, that would be Triton. Triton's running multiple models inside there. It gets the right requests, turns it into a prediction, sends it back, and out of the container we go. One of the things that we're exploring right now is an optimization to essentially solve, because like the scale has reached a certain point now that we start thinking about like performance optimizations. So we're looking now at doing shared memory between homogenated and Triton so that we're not manually like marshalling protos back and forth just between that homogenator and Triton pathway. I did want to pause just for a second to talk about batch inference, because I think you're probably thinking about like standard online inference for all those previous slides. Batch inference is when you have maybe like a CSV or some other data stream, maybe it has millions of rows, and you're like, okay, cool, I want to do an inference on that. I don't care that it comes immediately back, but it's like a job and I want it to eventually finish. My advice is not to mix the two together, especially when you have like finite availability. So, if you're not scaling infinitely, and you have like this CSV that you're trying to send inference from, generate inference from that CSV, and you're suddenly doing 100 queries per second from that CSV, but you have this little online workload that needs to be stable at 1 query per second, you can probably make that offline really quickly. Like you can kill that online inference and make it unavailable if you allow that offline inference to come into the same hardware. So I recommend splitting them out. And you also probably have different expectations around the in and out patterns. So with online inference, you're probably just saying, okay, give me that inference, get it back. It's standard synchronous gRPC or something. But with batch inference, you probably just want to write to a stream, put it to a CSV, put it on an S3, something like that. So we generally think about these things separately, and we provision hardware separately for batch. If you've been successful with all this inference, you also want to think about publishing new versions, and I recommend building that directly into your system. Because if you train a model, you have it sitting in production, and then you do another layer of research, and you find out, oh, cool, I can change architecture, and it's 20% more efficient. You do want to have a pathway to have like seamless migration from one version to the next one. And so we've built promotion and demotion directly into the platform. It also means when you deploy that new version of the model, you can allow shadow traffic to hit that model, confirm it's working, without sending those production inferences from the new model. Okay, so we've gone through the whole process, right? We've trained a model, we've deployed it, we make sure that we can talk to it. You're done, right? Like that's it, you can just walk away. You probably want to monitor it, right? So we like to think of monitoring in terms of questions, and charts are the answers for that. And some reasonable questions that you might ask, like how much load is going through the system? Is the system coping? Like, are things looking legit? And are there any anomalies? What can you see that looks wrong? This is the last one I think about as well, is like if I'm wanting to make sure the system's okay, what's going to keep you up at night? Like, what do you need to know so that you can confirm that you feel good enough to go to bed?
Yeah, so, and we can just sort of shift here a little bit since suddenly the magic word monitoring has come up. I feel like I've been asked to say a few things. So system load, network load, auto-scaling, those seem pretty basic stuff. Obviously, dashboards and setting up monitors and alerts are things that you're doing within your platform. If you want to go to the next slide, one of the things that we talked about a lot is at Datadog, we sort of think of the full AI tech stack and where you might have different tooling and different services that you need to keep an eye on in terms of that observability. As you look through this tech stack, are there any other services in here that you've either explored, that you're currently using, you're hopeful to integrate in? Just tell me a little bit what you think about this tech stack and how you're trying to create some observability throughout that.
Yeah, so I mean, if we look at this, like it's buzzword bingo for us. But we have to monitor our system at all those layers. So we're definitely monitoring everything at like a low-level infrastructure level. We're looking at our kube clusters. We're making sure that everything's, CPU, memory stuff, everything looks reasonable there. We're also using like Pinecone and different like data things that we're monitoring. We're across different clouds, and yeah, I think some of the good parts about Datadog are just, it has all these built-in integrations that we're using pretty heavily.
So, and speaking of integrations, if you want to go to the next slide, the SageMaker is what we're here talking about for the most part. And Datadog has obviously an integration with SageMaker. What you're looking at is pretty much the out-of-the-box dashboard. I don't know if you want to explain a little bit more of what you've done to expand on that sort of basic dashboard that was created. I know you use Power Packs, some parameters. Maybe you can share just a little bit about how you design your dashboards and all that.
Yeah, totally. So we have two responsibilities. One is we need to keep the platform up, which is something that is pretty important for us, and we need to monitor that platform. We also build systems for all of our customers, and our customers are the applied ML teams. So we use this pretty extensively in two different ways. One is we build dashboards for ourselves, and we also build dashboards for our customers, so that they can monitor their model's performance, so that they can see what's going on, how much traffic is coming through to it. And similarly, the same with monitors, things that just will automatically alert and hit PagerDuty and tell us when something's wrong, both for us and for our customers.
So it sounds like multiple dashboards. There's not just one single thing that tells you everything you need to know.
It's an army of dashboards.
Makes sense.
And with query params so that you can tell like which, I guess, target them directly for different teams.
Yeah, everybody loves to have their own design and tell the story that they need to hear.
Yeah.
So when it comes to application performance monitoring, I know this is another area that you've invested in terms of time. Obviously, detect outliers, that kind of thing. But maybe you can share just a little bit of what APM has done for you, what you're excited about.
Yeah, we use APM pretty extensively because we have a pretty high traffic platform. Like I think our platform comes through at 2,000 or 3,000 QPS at peak, and so we use APM to diagnose like the long tail for these requests. Like if you have like I guess we're not seeing every request come through there, so we have like 1% that we're whatever number that we're sampling. We're using that to diagnose, like dig into like the trace. You can follow the whole pathway of the trace. So it's like you have a request come in, it hits like 5 or 6 different services in our distributed system. We can see the whole stack trace through there as long as we set it up correctly, and that's been really useful for us.
Cool.
Yeah, I guess, okay, so you've gone through all of that life cycle, you've scaled your system, you've built your ML model out, you've trained it, you're talking to it, and you're making sure that it's humming along. If you're successful or the model has enough traffic, you probably want to scale it. And the way that we approach that is 2 different ways, and it kind of depends on whether we're doing single model endpoints or multi-model endpoints, and it also depends on the model type. So some models need really big instances. Stuff like large language models, which are the buzz right now. Like they need really big instances, and so you're probably going to want to scale that to be vertically, a larger single instance. On the other hand, when we have our multi-model endpoints, we scale that horizontally. So it's lots of those different models. They have pretty similar hardware requirements. We just scale that out and say maybe, okay, that maybe needs like 10 instances, 10 repeated instances of that same type for that multi-model endpoint. And we use SageMaker in that way. Like it has similar, like there's I guess an analog between EC2 and SageMaker. SageMaker is, essentially managed EC2. I don't think they're going to brand it like that, but you have similar instant types, and they can you can use the bigger ones, or you can have more of them. I did want to take some time just to talk about this because it's something that's not often highlighted. When you're an internal infra team, your customers aren't the same as your public customers. They're actually internal. So they will respond better if you treat them like customers rather than just people using your platform. So we try to treat them like external customers. And I mean ish because it's almost like customers that you have a better relationship with. Like they're in your Slack, they're people that you know day to day. So they're coming in, they're talking to you. You probably want to prioritize for impact. Like you want to work out how much you can build that's going to make their life as easy as possible. But in doing so, I do recommend that you manage their expectations. Like if you have several different teams that rely on your platform, you probably can't ship everything that they need all at once. So another way that we try to approach that is we have really extensive internal documentation. So if you're a platform team and you're trying to build stuff for your teams to use, writing docs is like the highest yield work that you can do, in my opinion. We also have this concept of being available in the sense that we often drop a lot of our in-flight work just to support customers. We have a channel that they come into. I'm having this problem uploading this model to this system. We just pair with them directly to fix some of their issues that are going on. And we just make sure that we're available, that they know if they're having any issues, they can come talk to us. And when you have lots of teams using your platform, because you have to pick finite bits of work that you can work on, we try to align the work so that it benefits lots of different teams. Now, you're going to always have, when you have this external platform, or this platform that you're running internally, you're going to have people that need to do more than the golden path that's in your platform. So we give the best path for people to do stuff. As soon as they need to do something hard, we don't want to stop them. So we don't restrict them from doing anything complicated, but we just try and support as best as we can the golden path, and then if they want to do anything else, that's of course their agenda. So there you have it. There's some of the problems that we've had to deal with trying to scale machine learning at Cash App, and some of the different solutions for that. At the end of the day, we started by trying to solve model hosting for one team, and another team was trying to do the same thing. Joining forces was the best thing that we could do, and now I'm lucky enough to work on that team, focusing directly on solving model hosting and inference for the entire organization. So a few little just takeaways, and then we'll have some time for questions as well. One is just to make sure that you identify overlaps in what different teams need and prioritize accordingly. You're not going to be able to build every feature that you need to that every team wants. So just try and find the highest value stuff, and abstract away complexity. Make it as easy as possible for people to ship their ML models to to production. The other part is building tools for independent slices of the stack can be really beneficial. Like we went through before, building a Python library so people can package their models really easily, or building UI so people can monitor their models. What you want to do is provide a better experience than direct integration. Make it much easier to use your platform than writing your own SageMaker integration. That's basically it. There's a few resources on here. There's some QR codes, some links to our blogs. But now I just wanted to pause and give everyone time to ask any questions if there are any. Yeah.
Good question. Any others?
Cool. I think we'll probably end it there. And,
okay. Yeah. Well, thank you so much for coming.
Thanks so
Enjoy
much.
the rest
Really
of your conference.
Yeah.
Great job, James.
Cheers.
Be sure to rate the session for us, and maybe we'll see you around.
Yeah. We'll be outside if anyone has any more questions. Thanks so much.
Thanks.